Very good morning. So, myself, Venugopal. If you observe here in our daily life, if we go for anything, it is related to measurements. If, for example, if you went to the market, so if you want to purchase the tomatoes or onions, he asks what you want or how much do you want, and we say that give me 2 kgs or 3 kgs. What it is? 2 kgs, 3 kgs are quantities. Yes or no? Same as to the measurement. If you go to the shop, so if you want to take a oil, so we have to take a 1 liter packet. 1 liter is the measurable quantity and which represents the quantity, and it is also have some measurement. See, from morning to night, if you want to take anything, it has a particular measurement. Yes or no? In our daily life, this measurement is very important. It will be plays a very important role in our daily life. So now today we are going to read that measurable quantities in these vectors. Generally, according to mathematical, it is divided into so many ways. The physical quantity will be divided into various types. Among them, we are going to discuss two important factors. One is scalar physical quantity, another one is vector physical quantity. Let me discuss. So first we are going to discuss. So in this physical quantities means it has various types. Various types. Among them, we are going to discuss two important types. In the first one is scalar physical quantities. Before going to discuss this, first let me discuss one example. If for example, if I will take the chalk piece, what is its length? What its length? It means we are taking one scale, 15 centimeter scale, and we can measure. Then we can say that length is to be 5 centimeters. Length is to be 5 centimeters. If for example for myself, what is my weight means, with the help of physical balance or weight machine, I am measured. So I can able to measure. So mass, what will be the weight? Weight is 80 kg. If you observe here, length 5 centimeters, weight 80 kg. Here cm, centimeter or kg, what it represents? Unit. What it represents? Unit, and this is a number. A number followed by a unit is called magnitude. If you observe these two examples, length has magnitude and mass also magnitude. That is nothing but a scalar physical quantity. What it is? Scalar physical quantity. A physical quantity which has only magnitude and which follows the algebra. So, a physical quantity which has only magnitude and follows the simple algebraic rules, that we call as a scalar. Examples are length. Examples are length is 5 centimeters, mass is 80 kgs. Here, so magnitude is nothing but a number followed by a unit. Next, let me go for another one. Second one is vector physical quantity. What is the vector physical quantity? First I will give example. A car started travel, move from east to west 30 kilometer per hour. A car move from east direction. Simple. A car travel in east direction 30 kilometer per hour. A car move east direction 30 kilometer per hour. So here 30 kilometer per hour is the magnitude, and east is nothing but direction. East is nothing but direction. So a physical quantity which has both magnitude and direction is called vector physical quantity. A quantity which has both magnitude and direction. A physical quantity which has both magnitude and direction, and it follows that vector law of addition. So what is a vector quantity? A physical quantity which has both magnitude and direction. And it follows that vector law of vector addition. That is, the example is a car is moving east direction with 30 km per hour. So east is represents as a direction, 30 km per hour is represents as a magnitude. So which has both magnitude and direction is called vector physical quantity. Next, let me discuss how we should represent a vector. Representation of a vector. Next, let me discuss about representation of a vector. How we should represent a vector? Example, if we take a AB bar or A bar, how we should represent the vector means a alphabetic number, a alphabet which is on overhead as arrow, an alphabet which has overhead is arrow, that is the representation of a vector. Example, A bar or AB bar. A alphabet on overhead which has an overhead is arrow, that is the representation of a vector. Next, types of vector. Next, let me discuss types of vector. So we have different types of vectors. Let me discuss now. Types of vectors. Equal vectors. And that first one is equal vectors. If for example, if you take two vectors have same direction. If you observe here, I am taking two vectors, A bar and another one is B bar. If a vector which has same direction and magnitude, that we call as an equal vectors. See here, these two vectors have same magnitude and both are moving in same direction, that we call as a equal vectors. In equal vectors you should keep in mind both two vectors are equal magnitude and equal same direction. And another one is negative vectors. If you observe here, negative vector, a vector mutually opposite direction which has same magnitude. Magnitude is same, but direction is different. So a vector mutually opposite. A vector mutually opposite in opposite direction. Mutually opposite with the same magnitude. With same magnitude. Next one is unit vector. Unit vector, a vector whose magnitude is equal to 1. A vector, for example, this is a unit vector, a vector whose magnitude is equal to 1, that we call as a unit vector. Next, null vector. Null vector is nothing but a vector whose magnitude is equals to 0. A vector whose magnitude is equal to 1 is a unit vector. A vector whose magnitude is equals to 0, that we call as a null vector. Next, let me go for co-initial vector. If you observe here, some of the junctions are there, that all junctions will be started with the same point. Okay, so here what is co-initial vector?